Okay, we're going to go through a few more examples. Example 4, we have the equations y equals negative 3x plus 1 and y equals negative 2. For y equals negative 3x plus 1, we have a y-intercept at 1, so I'm going to put a point where y is equal to 1. And then our slope is negative 3, so that means we are going to go down 3 and to the right 1. So down 3, 1, 2, 3, to the right 1. Down 3, 1, 2, 3, and to the right 1. So I'm going to connect those points, myself a nice straight line, more or less. It's a little crooked. Let's see if I can fix that. There we go. That's a little bit better. Okay. And then we have the line y equals negative 2. So if you remember from Hoy-Vux, y equals a number is a horizontal line at negative 2. So a horizontal line at y equals negative 2. Here we go. So we notice that, yes, these intersect. And they intersect at 1, negative 2, and that is our one solution. Our one solution is at 1, negative 2. Example 5 here, we have y equals negative 2x minus 5 and y equals negative 2x plus 3. If you notice, these have the same slope. If they have the same slope, they are parallel, and they're never going to intersect. So there's no solutions. Now, we can go ahead and graph this if we want, just to make sure that we understand. So we have y is equal to negative 2x minus 5. That's our y-intercept at negative 5. And we have a slope of negative 2. So that means we're going to go down 2 and to the right 1. I run out of space here to do that. So we can also do the opposite, which is up 2 and to the left 1. So up 2 and to the left, up 2 and to the left. And we have some points to make ourselves a line. Then I look at my second equation, y equals negative 2x plus 3. We have a y-intercept of 3, so positive 3. And then we're going to go down 2, 1, 2, to the right 1, down 2, to the right 1. And we notice that those lines are never going to cross each other. They are parallel. Therefore, we have no solutions to this situation. And lastly, I have y equals negative 2x minus 3. So we have that y-intercept at negative 3 and a slope of negative 2, which means we go down 2 and to the right 1, down 2 to the right 1. And if you need to go the opposite direction, up 2 and to the left 1 to get enough points to make a line, you are welcome to. Give myself a couple of points. There we go. I have a line for y equals negative 2x minus 3. Now, my second equation says 6x plus 3y equals negative 9. This is not in slope-intercept form, so it's going to be a little more difficult. We're going to need to turn it into slope-intercept form, which is y equals mx plus b. So I am going to first start by moving the x to the right-hand side by subtracting 6x to both sides. So we have 3y is equal to negative 6x minus 9. And then to get the 3 by itself, I am going to divide by 3. To get the y by itself, I'm going to divide by 3. Divide by a positive 3. Divide by 3. On the left-hand side, 3y divided by 3 cancels out the 3's. We're left with y equals negative 6x divided by 3. Negative 6 divided by 3 is negative 2x. And then negative 9 divided by 3 is negative 3. So if we notice, y equals negative 2x minus 3, y equals negative 2x minus 3. These are the same line, so they are not going to intersect. Because they're the exact same line. They're going to intersect always. They are going to intersect always. Same line. So this means we have infinite solutions. Infinite solutions. So all the numbers, if I graph this second line, it's just going to hang out on top of the first line because they are one and the same.